This is the final 6.2b video, and we're going to look at finding probabilities involving the sum or difference of independent normal random variables. So our first example, we're going to look at some lids and cups. The diameter, C, of the top of a randomly selected large drink in a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01. The diameter L of a randomly selected large this restaurant follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inches. Assume that L and C are independent random variables. So the size of the lid doesn't influence the size of the cups, and the cups don't influence the size of the lids. Let the random variable D equals L minus C be the difference between the lid's diameter and the cup's diameter. Describe the distribution of D. So that would be the difference between the lids and the cups. So first I want to draw out what we know about these two distributions that they've given to us. Okay, so I've drawn the picture of the distributions they told us about. The lids are normal with a center of 3.98, and the cups are normal with a center of 3.96. So what we're doing here for this final distribution is we're going to randomly pick, if you imagine randomly picking the lid, and then randomly picking a cup and subtracting the difference between their diameters, we're going to get some value. And if we started plotting all of those values, we would look and see the distribution will look something like this. If we're comparing, or if we're combining two random normal distributions, the result will also be normal, but we should expect it to have a little bit more variation because there's variation in the cup lid length or the cup diameters, and there's variation in the lid diameters. So when we combine them or subtract them, we should expect a little bit more variation in their combination. But we can describe this distribution as having a center of the difference between these two values, the means of the lids and the cups, and the standard deviation is going to be the combination or the addition of their variances with the square root being taken. So I'm going to write out the information describing this final distribution based on its center, shape, and spread. So like I said before, if we're combining two normal distributions, the resulting distribution will be normal. The center is going to be the difference, like we've seen in previous videos, the mean of the lids minus the mean of the cups, for a center of 0.02 inches. And the standard deviation is going to be their variances added together. Even though we're subtracting, we should remember that we always add variances together. We don't add standard deviations, just variances. So that's where the 0.2 is the standard deviation of the lids, squared is the variance, and 0.1 is 0.01 is the standard deviation of the cups. Squared gives us the variance. Add them together and take the square root to get a standard deviation of 0.0224 inches. And that describes this distribution that combined the lids and the cups. So now we can use this distribution to answer questions about probabilities. For a lid to fit on a cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. Find the probability that a randomly selected lid will fit on a randomly selected cup and interpret this value. So we've got to think about what this means. We are using the equation difference of the lid minus the cups. So think about the different values here. If D is a positive value, that means the lid is larger than the cup. If D is a negative number, that means that the cup is larger than the lid. So we know that the lid has to be larger in order for it to fit onto the cup, but it can't be larger than 0.06 inches. So from this distribution where the mean is 0.2 inches and the standard deviation is 0.022 inches, we want to find the probability of getting a difference that is greater than 0 but less than or equal to 0.06. We want to find the value where where it's greater than 0 but less than or equal to 0.06 because this is the size of the difference where the cup fits on the lid. That's what they've told us in the problem. So now we're going to use the normal distribution, the density curve, and calculate the area from 0 to 0.6. And remember, whether this is equal to or less than, whether it's equal to or just less than, we're going to get the same area between these two values. So I'll write out our calculator statement. And so we'd punch this in the calculator using normal CDF, where our lower is 0, upper is 0.06, the mean and the standard deviation, and we would get a probability of 0.777. So there's about a 77.7% chance that a randomly selected lid will fit on a randomly selected cup. Let's look at one last example of combining random variables that are normal. And remember, normal distributions are always represented by density curves. So we have Mr. Starnes, and he likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, Mr. Starnes adds 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What's the probability that Mr. Starnes' tea tastes right? So first, let's identify what our random variable is. We have packets of sugar, and we'll call those X. So X represents the amount of sugar in a randomly selected packet. The mean is 2.17 grams and the standard deviation is 0.08. But what we're doing here is we're picking, or Mr. Starnes is picking 4 packets of sugar. So we need to come up with a new variable that describes him picking 4 packets of sugar and how much sugar is in all 4 packets. So I'm going to write out another equation to represent that value. So T is the total amount of sugar of all 4 packets that's added to the T. And what a lot of people think is the equation for T is going to be T equals 4 times X. But that is actually wrong. It is not 4 times X. It is X plus X plus X plus X, which is different because what this equation means, T equals 4X, that would be expanding one packet 4 times the amount. So it wouldn't be picking 4 different packets. This would represent picking one packet that is 4 times the size. So this equation doesn't apply to the situation. We actually have to add X to itself 4 different times. So instead of 4 times X, our equation is actually going to be X1, which represents the amount of sugar in the first packet, plus X2, which represents the second, and 3 the third, and 4 the fourth. And if you think about this, it can't be 4 times X, or we'd be incorrect using 4 times X because that will give us the wrong standard deviation. Think about how we'd the mean of this distribution. We would add the means of X 4 times in a row, but the standard deviation for 4X, we would multiply the standard deviation of X times 4, but here we actually have to add the variance together 4 times and then find the square root. So let's calculate the mean of the correct formula for T and the standard deviation for the correct formula of T. So we find the mean to be 8.68 grams and the standard deviation to be 0.166 grams. So what that means is if we repeated this process over and over again and we picked 4 packets, on average we'd expect there to be 8.68 grams of sugar, and the typical distance from that mean would be 0.16 grams. So now we can draw this new distribution for T to try and figure out the probability that Mr. Starnes' tea tastes correct. Because if there is between 8.5 and 9 grams of sugar, then his tea will taste correct. So what's the probability of 4 bags having that amount of sugar in it? And so this is the distribution of T, normal with a center of 8.68 and a standard deviation of 0.16 grams. So the probability of t, or roundly speaking, 4 packets, being between 8.5 and 9 is in this shaded region here. So we use our normal calculation statement to figure out the probability of the distribution being between 8.5 and 9. So just like normal, we'll do a normal calculation statement where the lower is 8.5, upper is 9, with the mean and standard deviation from the distribution. So there is about an 85% chance that Mr. Starnes' tea will taste right. So what you need to know about normal distributions is that when you're setting up your equation like I did here, x1 plus x2 is not the same as 2x. Or for situations when an individual observation is doubled, we use 2x. But for situations involving repeated observations from the same chance process, we have to use x1 plus x2. And that's primarily because the standard deviation, the variation from the distribution, is different if we just double it versus repeating the same process. So what I'd like you to do is take a look at the independence practice problems that we have and check your work with my work as you go through.